Right, before the break we said that the body has to maintain a balanced or a level internal environment, and it does so by the process of homeostasis. How does it work in that way? Well, one of the control mechanisms that you need to know about for your matric exam is something called negative feedback. So how does negative feedback work? Well, negative feedback is, for example, a child doing something wrong and then getting a smack for it or being moaned at or shouted at. That's negative feedback. Positive feedback is if the child does something right and then you praise that and hope that they go away and learn that, well, it's good to do good things. But negative feedback is what happens in your body when substances build up to certain levels. So let's have a look at how this actually works. We have a process, for example, in your body that's going to build an end product. The concentration or amount of this end product is going to build and build and build, and eventually the levels of that end product are going to reach a critical state. And at that critical state, they are going to negatively feed back to the process to say, stop the process. We have enough of this end product being made. And the end product will be used up by the cells, and slowly the amount of end product will become smaller and smaller. And so the process will begin again. It will be stimulated to make more of the product. The product will grow in concentration, grow in concentration. At the critical point, it will switch off the process that made the end product. That is how negative feedback works. Lots of different systems within your body work on a negative feedback system. And the one system of homeostatic control that we're going to look at in a little more depth today is the control of glucose levels in the blood. So, what we're aiming at, of course, is a normal glucose level in the blood. That's what we want to maintain. We need to maintain the levels of glucose not very high, or we're going to have capillary damage, not very low, or we're going to starve ourselves and of glucose in our cells and go into a coma. So we need to maintain normal sugar levels. Now, let's say something happens that we have high blood glucose. You go out with your friends and you pack away an ice cream, a waffle, a milkshake. You've suddenly got a huge sugar high in your body. You've got lots of glucose circulating in your blood. And immediately your brain registers, as the blood passes through the brain, it registers too much glucose. And so there is a receptor, something that's going to pick up the stimulus, and the receptor sends a message to the pancreas, which is an organ kind of in your abdomen near where your stomach is, and the pancreas is instructed to secrete insulin. Insulin is the hormone that controls the blood sugar levels. And so insulin is pumped into the blood. What the insulin does works in two ways. First and most simple way of the two ways, it makes the cells take up more glucose. It instructs the cells, it opens channels on the cell's membrane for glucose to flow into the cells. But the cells can only take up so much glucose. What happens to the excess glucose is that the insulin instructs the liver to store the glucose, and it's changed into the form of glycogen. And the glycogen is packed into the liver and is stored. But both of these processes, 1 and 2, have effectively removed glucose from the blood. The glucose has either been packed into cells or it's been stored in the liver. And so therefore, our glucose levels are going to fall and we're going to get back to normal blood glucose levels. Whereas in the beginning, it was going too high. What if the reverse happens? We have the glucose levels falling. It's a long time since you had your lunch and you go out onto the sports field and you're playing soccer and you're running around and you're using all of this glucose that was in your blood from your lunch 3 hours ago. All right, your blood glucose levels are dropping dangerously. You might even start shaking. You might feel that you are feeling a little bit faint or dizzy. Once again, message is sent to the pancreas to make another hormone called glucagon. Glucagon goes into the blood and it is going to instruct the liver to release glucose. It kind of does the reverse of that process of the insulin, where the glucose is released from glycogen that has been stored, pumps that glucose back into the blood so that our glucose levels are going to rise in the blood, and once again we hit normal blood glucose levels. And this homeostatic control mechanism is how many of your different factors, substances inside your body are kept at a normal level through negative feedback. This is only one of the examples. Look in your textbook, talk to your teacher about it. You need to know about carbon dioxide, temperature, pH, and so on. Next week, we'll look at homeostatic control of temperature.